We all think we know the story of the Apollo moon landing, right? Giant leaps for mankind, famous one-liners. But what if I told you a huge part of that story, maybe the most important part, wasn't about rockets at all? It was about needles and thread.
So, look at this. What do you see? It looks like someone is weaving, right? Like making a tapestry. But the caption, it just says programming. That doesn't make any sense, does it? Well, turns out this single picture unlocks one of the most mind-blowing hidden stories of the entire space race. I mean, it sounds crazy, but it's true. The software that guided astronauts to the moon, it wasn't typed out on a keyboard. It was literally woven, stitched together by hand. And today we're going to pull back the curtain on the incredible women who did it.
Okay, so to really get why this was so revolutionary, we have to go back to the 60s and understand the absolutely massive problem NASA was staring down. They needed a computer to fly to the moon. But pretty much every computer on Earth was a giant, fragile beast stuck in a room.
Just look at the difference here. Back then, a computer was a mainframe. We're talking room-sized machines, super delicate, running on flimsy magnetic tapes. But for the Apollo mission, you needed the complete opposite. It had to be small, it had to be tough, and, this is the big one, it could not, under any circumstances, fail. It had to be basically indestructible.
And get this, the memory limit was just 72 kilobytes. 72! Today, a single blurry photo on your phone is bigger than that. So with that little space, every single bit of code was gold, and you couldn't just store it, you had to make it permanent, absolutely bulletproof.
So what did they do? They came up with something that was, frankly, genius. A totally new kind of memory. It was this wild idea of turning software from something you just think about into something you could actually touch. They called it core rope memory. The whole point of core rope memory was to basically turn the software into hardware. Think about that. The code wasn't just stored, it was physically built into the machine, woven right in. That meant nothing could erase it. A power outage? Nope. Cosmic rays zapping it in space? Not a chance. The code was locked in, permanent.
And this is what it was made of. The whole system was built with these tiny little magnetic donuts. They were called cores. You can kind of think of them like beads on a wire, except instead of counting, each one was holding a single piece of the flight code, a 1 or a 0.
And the way it worked was just brilliant in its simplicity. If you threaded a wire through one of those little rings, that was a 1. If the wire went around the ring, skipping it, that was a 0. That's it. 1 and 0. Through or around. Every single command to get to the moon and back was just a long, long sequence of those two choices.
So, if the code was literally woven, that begs the question, who were the weavers? Yeah, this wasn't some machine doing the work. This was all done by hand. It was an incredibly precise, painstaking job done by a group of highly skilled women whose names, for the most part, have been lost to history. Let's change.
Okay, so in Massachusetts, near Boston, a company called Raytheon got the contract to actually build this memory. And they were smart about it. Where do you find people with the dexterity and focus for this kind of work? Well, they went to local textile mills and watch factories. They hired women who were already masters of fine, detailed work.
And you have to understand, the stakes were astronomical. I mean, literally. This thing they were weaving, it was the brain of the Apollo command module. One wire in the wrong place, a single 0 where a 1 should be, and that could mean, well, you can imagine. A tiny mistake made in a factory on Earth could lead to total disaster hundreds of thousands of miles away in space.
Now, at the same time, hundreds of miles away in Shiprock, New Mexico, another absolutely critical piece of the puzzle was coming together. A company called Fairchild Semiconductor opened a factory there, and its workforce was made up almost entirely of Navajo women.
Now, their job was different, but just as complex. They weren't weaving the rope memory itself. They were assembling the brand new, cutting-edge technology of the day, integrated circuits, microchips. And this was incredibly high-tech stuff, all done under a microscope, demanding just unbelievable levels of precision.
So you've got these two groups of women in two different places, both doing this essential, super skilled technical work. But here's where the story takes a turn, because how their work was seen at the time and how it was talked about is a whole other part of the story.
You would think this life-or-death work would be treated with reverence, right? Not exactly. It got hit with all these condescending nicknames. Can you believe they called it lol memory for little old ladies? It was dismissed as just women's work, a no-brainer, like it wasn't a technical skill, it was just something that needed, quote,
tender, loving care.
And I'm not making that up. That quote comes directly from the guy who led the hardware design, Eldon Hall. He literally described the process as requiring tender, loving care. It's this perfect example of how this incredibly complex technical job was framed as, I don't know, something emotional instead of scientific.
But let's contrast that with the reality on the factory floor. Here's a quote from Mary Lou Rogers, one of the women who actually did the work. She said everything had to be checked by 3 or 4 different people. They had federal inspectors looking over their shoulders constantly. This was no knitting circle. This was intense, high-pressure, high-stakes manufacturing.
And it wasn't just in Massachusetts. Down in New Mexico, Fairchild's own marketing department would compare the Navajo women's work assembling microchips to, of all things, traditional rug weaving. Now, on the surface, that might seem like a compliment, but it really wasn't. It reinforced stereotypes, and more importantly, it kept them from getting the recognition and the pay that this kind of high-tech labor deserved.
Thankfully, people are starting to set the record straight. There are projects today, like one called Making Core Memory, that are all about honoring this legacy. They've even created this electronic quilt where you can try weaving a piece of memory yourself. And let me tell you, when people try it, they finally get just how incredibly difficult and skilled this work actually was. It completely shatters that old idea that it was some simple, unskilled job.
But maybe the most damning piece of evidence comes from NASA itself. In a 1975 report looking back on Apollo, they called the computer's performance flawless. They said it was perhaps the most significant accomplishment of the whole program. High praise, right? But in that entire report, not a single mention of the women who built it. Not one. Their names, their work, just erased.
And that really leaves us with a huge question, doesn't it? Our technology is amazing at remembering the code, the ones and the zeros, but it has no memory of the human beings who made it possible. That part's up to us. It really makes you stop and think, right? Who are the hidden figures, the unsung weavers behind all the technology we take for granted today?